Hey, Talking Lunch Math and History, and we are going to take a look at graphing trinomials, but we're going to do it with polynomials. So what we're going to do is we're going to understand, as a review, how to graph these kinds of equations. So instead of actually going through step by step, we're going to focus more about the ergonomics and the mathematics than just solving, guessing, and answering, so we can make it more simpler. So, the first question is, there is an actual equation right there. But, how does that relate to this graph right there? So think about it for a bit. Pause the video if you need more time. Okay, so one thing you might have noticed, which is very easy to understand once you learn it, is notice how there are different points on the graph where they behave differently. This one strikes, this one bounces off, and that one pauses, then strikes upward. How does that work? Well, here's what happens. Notice how there are three things that are separated. There's an x plus 2, an x minus 1 squared, and an x minus 3 to the power of 3. What we can do is, if we equal all of these objects to 0, x plus 2 equals 0, x minus 1 equals 0, and x plus 3 equals 0, if you do the zero product property, x is going to equal negative 2, x is going to equal positive 1, and x is going to equal negative 3. And the funny part is that these x's can turn themselves into the x-intercepts, and the x-intercept is what is going to be literally lying on the x-axis. So this is the coordinate negative 2, 0. This is the coordinate for 1, 0. And that's the coordinate for 3, 0. But something still doesn't explain it. How do we explain the behavior for this graph? So we know that there are different points on the x-axis. And we know that there's some kind of behavior going around that we don't know of. So what can we do with that? Well, to understand the behavior, here's what happens. Look, if you notice on the x minus 1 squared, there's a number 2 as the exponent. And for the x minus 3 cubed, there's a number 3 on the exponent. So we're going to write 1, 1, 2, and 1, 2, 3. Meaning that in the mathematics for the work, this shows up once, that shows up twice, and that one shows up 3 times. To put it on a graph and a perspective, here's what happens. If it appears once, it's a single line. If it appears twice, it looks like a quadratic. Therefore, it bounces off the dot. And for the last one, it just pauses when it goes up. Then it strikes right up to the sky. And that's what happens if you get 3 times. So that explains the behavior of this graph. We're going to write negative 2, 0. We're going to write here 1, 0, and 3, 0. But there is still something missing about the problem. Not the graph. This kind of problem. Notice how there's some kind of question mark? We don't know what that letter A is. We have no idea what that question mark is right there. So how do we solve it? What we can do is pick one of the x-intercepts and then plug it in to get to an answer. What we're trying to do is get to the y-axis, but in reverse. Or the y-intercept in reverse. Saying, if this was 0, and this is x and y, for one of them, we can put negative 2 here, negative 2 here, and negative 2 here, and see what's missing. So negative 2 plus 2 is 0. Negative 2 minus 1 squared is negative 3, 9, and x minus 3, we have negative 5, negative 15, as the last part for the 3. So, we have 0, 9, and negative 15. What if I told you that what I've been leading you into is actually a trap? Because if you try to put a 0 into one of the x's, it's not going to work because you don't know what the y is. But if you try to put an x-intercept in, you will get a 0 as a multiplier, and anything times 0 is 0, so it wouldn't really work. The problem would have to give you a point other than the x-intercept, or literally state what the question mark is in the first place. So what we're going to do is move on back to the graph. So we are back at the graph, and the next thing we're going to take a look at is the minimum and the maximum, right over here. So the min and the max are supposed to kind of describe where everything is going, what direction, but also literally what is the min and the max. For example, an absolute min or max is literally the absolute that there is. And in this case scenario, it's infinity. We're talking about the y-axis going up and down. For a relative minimum, the infinity is the maximum. For an absolute minimum, I'm going to say right there, that's negative 13.5. 0, negative 13.5. Saw this on Desmos, and it literally said on the y-intercept, negative 13.5. So that is going to be the absolute minimum. The relative minimums are going to be right here, because it's almost not the actual minimum, it's one of them, which I'm just going to take a guess, where it's like 1.5, negative 0.5. We found the absolute maximum, but what about the relative max? Well, we have one right here, and that is going to be, we have a max right here, and a max right there. So we can say that the x-intercepts are also the maxes too. Well, just these two. So 1, 0, and 3, 0. So that is the min and the max. What about the increasing and decreasing? So this is pretty much the same idea, but instead of the y, we focus on the x. So we have to focus if it's increasing or decreasing, meaning you go from left to right. Let's take a look at increasing. So where on the point is the graph increasing? Like the starting point. Yeah, it's increasing right here. And right there, we can say 0, negative 13.5. But that's not the only time it increases. It's also increasing right over here, which is negative 1.5, and actually positive 1.5, negative 0.5. I'm just making my best guess, because a lot of things you get in pre-calculus and algebra, when you try to make these kinds of mathematics works, your teacher's not going to penalize you if you miss things by a tiny decimal. And since you have two increasing points, they're going to be union together, stating that there's more than one. What about decreasing? Well, it goes from all the way to the top to all the way to the bottom. So what's going to happen is we are going to say negative infinity to 0, and it's going to be union with. Here is 1 point, here is 1. Here is 1 to 1.5. So 1 to 1.5. But there's a problem. The top one, we just listed coordinates, which another trap we cannot do. So we have to focus on the x. So it starts to increase at 0. So we're going to put 0 right there. And it stops at 1.0. So we're going to say it goes 0 to 1, and it's going to be union with 1.5 to infinity. So the common mistake that we made is we made it with coordinates. But what we're supposed to do is list them out, saying here it starts, then it ends, then it pauses, then it starts, then it ends. And that is how you find whether something is increasing and decreasing and where. And that's also how you understand polynomials on a graph going from here all the way to here. Very simple and very fast. This was a review video. If you haven't learned this yet or haven't grasped the understanding, try to watch the other video we made for Algebra 2 towards the last part of the year. I hope this video has helped you understand reviewing graphing trinomials, polynomials. Thank you for watching Top Analyze Math Industry. Like and subscribe.